Welcome back to Gopinath's mathematics class for surface area and volume part 3. Question is spherical marbles are dropped in a cylindrical beaker. There is a cylindrical beaker. In the cylindrical beaker, spherical marbles are to be dropped. Initially, this cylinder filled with some water. This is the water level. Up to this much water was there. But when the marbles are dropped here, few marbles are dropped here, the water level raised. Suppose this much of water level is raised. This is the raised water. As much marbles we dropped, that much water will be raised. So volume of all marbles we dropped is equal to volume of raised water. Diameter of each marble is 1.4, so radius is equal to 1.4 by 2, that is 0.7 cm. Okay, few marbles. And beaker diameter also given, that is 7 cm. So beaker radius is, I will take capital R for beaker's radius, that is 7 by 2 cm. You can write it as 3.5 cm. 3.5 cm. Now the question is, how many marbles are dropped so that the water raised up to 5.6 cm. So the height of the raised water is 5.6 cm. Now you have to find number of marbles. That means suppose n number of marbles are there. So volume of all n number of marbles is equal to n into marble is sphere formula 4 by 3 pi r cube, 4 by 3 pi radius is 0.7 whole cube is equal to raised water is in cylindrical form. So cylinder formula pi r square h, pi big R is here 3.5 whole square into height is given 5.6. So you have to find n value. Therefore, that implies n is equal to, you can cancel pi from both sides. Pi cancel, bring that side. So it is 3.5 whole square is there into 3.5, 5.6 is there, 5.6 whole by, these will come that side, that is 0.7 whole cube. You can write as 0.7 into 0.7 into another 0.7, and 4 by 3 will be 3 by 4, denominator 4 and numerator 3. Now cancel. 0.7 cancel with 3.5 by 5 times. Like that, 3.5 and 0.7 5 times. 0.7 5.6 8 times. And 4 8 2 times. So now 5 into 5, 25 into 2, 50 into 3, 150. So n is equal to 150. That means 150 number of marbles are dropped so that the water level will raise up to 5.6 cm. This is your first question solution. The next question is a cylindrical container of diameter 12 cm contains ice cream and its height is 15 meter. Its height is 15 cm and the ice cream is to be transferred into cone shape, cone with hemispherical top. So few such cone ice creams are to be formed with the ice cream in the container. And the diameter of a cone ice cream is 6 cm, and the height of the cone is 12 cm. Question is, how many cone ice creams can be filled with the ice cream in container? So volume of ice cream in container is equal to volume of all the cones. Let we consider there are n cone ice creams can be formed. So volume of n cones will be cone formula 1 by 3 pi r square h, r square h, plus as hemispherical top is there, that is the volume of hemisphere is 2 by 3 pi r cube. Okay, so this is the volume of one cone ice cream, and n numbers are there, so n is to be multiplied. So now take pi r square and 1 by 3 common. So 1 by 3 pi r square taken common, here h plus here 2r, 2 and r cube gone, so r. That implies that is equal to n into 1 by 3 pi r is 3 cm, diameter 6 given, so r is equal to 3 square. H is equal to 12 plus 2r means diameter is 6. So that equals to n into pi into 1 by 3 into 9 into 12 plus 6 is 18. So 6 times, therefore it is 9 6 are 54, n pi is the volume of all cone ice creams, and this is only equals to the volume of cylinder. So 54 n pi is the volume of cylinder. Volume of cylinder formula pi r square h, pi big R square into h2, that equals to pi, diameter 12, so radius will be 6 square, into height 2 is 15, and this volume equals to volume of all cone ice creams. Therefore you can equate them. Pi into 6 square, 36, into 15 is equal to here 54 n pi, 54 n pi. We are going to find the value of n. So transfer to left side, pi into 36 into 15 by 54 pi is equal to n. That implies you can pi can be cancelled now. 9 4 times, 9 6 times, 2 2 times, 2 3 times, 3 5 times, so 2 into 5 10, therefore n is equal to 10. So 10 such cone ice creams can be formed. Okay, come to the next question. A metallic sphere of diameter is equal to 28 cm is melted and recast into small cones. Question is, how many small cones can be formed? For the small cone, diameter given, diameter is equal to 4 fill 2 by 3. That is 3 4s are 12 plus 2, 14 by 3. So its radius will be 14 by 3 half, that is 7 by 3 cm. And height of the cone also given as 3 cm. Here diameters for sphere, radius will be capital R, take 14 cm. This sphere is melted and recast into small cones. So volume of sphere, that is 4 by 3 pi r cube, is equal to volume of n number of cones are there, n into volume of cone, that is 1 by 3 pi r square, take small r square into h. So now cancel, pi can be cancelled, by 3 can be cancelled. So here 4 into r cube, r is 14 cube, is equal to n into r square means 7 by 3 whole square into h means 3. Now bring these numbers to left side, that is 4 into 14 into 14 into 14, 7 by 3 whole square, and will come to left side, reciprocal, 3 square 9 and 7 square 49, 9 by 49 into 3 when come to left side, 1 by 3 is equal to n. Now cancel, 7 times, 7 2 times, again cancel 7 2 times, and cancel 3 with 3 times. So your answer will be 4 into 14 into 2 into 2 into 3, and that is 672 is equal to n. That means there are 672 number of small cones can be formed. Okay, come to the next question. Today's last question is a cubical wooden block. This is a cube. From this wooden block, from one face, one hemisphere is to cut out. This is the hemisphere, it is to be cut out. That means from, if you see top view will be like this. This is the top, and front view you can see like this. Okay, a hemisphere is cut out. For clear understanding, let us see, suppose it is a cube, and from the top view, it is the top view, a hemisphere is to be cut out, means it is a hemisphere, let it be. Of course, hemispherical depression it should be, not like this. Okay, and you can see 4 corners like this. Okay, here in this diagram, the 4 corners are there. Now the question is, after this hemisphere is scoop out, what is the total surface area of the remaining block? So how to find? Let the edge of cube is, each side is equal to a, and hemisphere diameter equals to edge, because the hemisphere is to completely fit here. Therefore radius will be a by 2 units. Now total surface area you have to count. As you know, total surface area of cube is 6a square. 6a square. But when you see in front view, a circular hole you can see. That means circle is not there. Therefore you have to do minus area of that circle, that is pi r square. But what happens when the cavity is formed? The curved surface area of hemisphere is generated, created. So that is to be added here now. So hemisphere formula is 2 pi r square is to be added. So the result is now like this: 6a square minus pi r square plus 2 pi r square is equal to pi r square. That implies 6a square plus pi, r means a by 2, a by 2 whole square. So take a square, a by 2 whole square means you can get a square by 4. Take a square common here. When you take a square common from first term 6 plus pi a square by 4, a square gone, pi by 4, pi by 4. it is the answer of, that means total surface area of the remaining block. So square unit. Okay, thank you, bye bye.